Hi everyone, this is me, Dr. Nasih from Physics Department, College of Science, Salahuddin University. In this tutorial, I'm going to solve two examples for combination of different type of connection of resistors. As you see in the first example, requirements through this circuits are: A, find the equivalent resistance of the circuit, and B, what is the potential drop V1 across this resistors, which is nominated by R1, it is 1 ohm, and C is find the current I2, which is going through the resistors of R2. To do so, first of all, we're going to find out the net resistance. As you see, these two are being connected as a parallel combination. For parallel combination, this is a formula, and this parallel result of these two parallel connections is in series with the resistance R1. As you see, R1 is in series with result of the R2 and R3. As you can calculate, the equivalent resistance will be 5.10 ohm for the whole circuit. And when we want to find out the potential drop, first of all, we need to find out total current, which is total current is equal to I1. To do so, we have to divide the potential difference, all potential difference or net potential difference, by the equivalent resistance, which means the result will be the current passing through this resistor is 2.35 amps. This is the result of I1, or the net current. And to find out this potential drop across this resistance from the result of I1 and the amount of resistance of this resistor, we easily can find out the potential drop, which is 2.35 volts. When we found out this potential drop, easily we can find out the potential difference across these two. When we know a potential difference across this one plus potential difference, this one will be 12. So 12 minus this potential difference across this one will be potential difference across that one. Easily we can find out this potential difference. As I said, we know this potential difference equal to net potential difference minus potential difference across this one, which means the result will be 9.65 potential difference across this one. So when we know the potential difference across this one, which is equal to potential difference across this one, and we know the amount of the resistance R2 is equal to 6, we can find out the current passing through the R2 resistance, which is I2. As I said, from V2 and R2, easily we can find out this current passing through the resistance of 6 ohm. For the second circuit, we want to find out the currents in total currents and currents passing through these two branches. To do so, first of all, we need to find out the net resistance or equivalent resistance. If we look at this circuit, these two are being connected in series. These are R3 and R4 in series. So the formula of series, we can add both of them together for resistance. Result will be 10. And result of these two will be in parallel with this one, which means R2. Result of those R3 and R4 was in parallel with this one. For parallel, we know this is a formula for the parallel. So the result of this two will be 5 ohm, and result of these two will be in series with this one. So the result of series will be 12. So the resistance equivalent of the whole circuit will be 12 ohm. From this 12 ohm, we can find out the net current or total current or currents passing through the main resistance, which means I1 is potential difference, the V net divided by R equivalent, which means 24 divided by 12, 2 amps. And to find out the potential drop across this one, we easily can find out from the 2 amps multiplied by 7, which means 14 volts. This is 14 volts potential drop. So we can find out the potential difference across these two, 24 minus 14, which means 10 volt. 10 volt will be across this branch and those two as well. From this 10 volt, we can find out 10 volt divided by 10 will be current through this one, and 10 volt divided by the result of these two as well will be a current through these two. So will be I2 is equal to V2 divided by R2, which means 1 amp. For the other side, for this two will be V2 as well, 10 volt divided by the result of these two. Result of those two was 10 ohm, so will be 1 amp as well. We had 2 amp through this one, and 2 amp goes to this junction. 1 amp was going to this one, and 1 amp goes to the other one. So 1 plus 1 will be 2. So the amount of the current going into this junction will equal to the amount of the current going out to the junction. This was a result of both examples. Please check that with your homework and let me know if you have any more questions. Thank you very much.